Hey guys, so welcome back to yet another video. In this video, we're trying to solve the problem, can I square in Codeforces? Okay, Karen has n buckets, the ith of which contains a of 5 wooden squares of side length 1. Can Karen build a square using all the given squares? Okay, so basically, your first input will be the amount of cases you have. So here it's 5, so we have 5 cases 1, 2, 3, 4, 5. For each of these cases, you will have the number of inputs. Okay, now here 1 means you have one input, 2 means you have two inputs, and so on. So basically, what you're supposed to do is that, like, say for example, we take this case, we have 2, which means we have two inputs. So we have 14 squares and 2 squares. So in total, we have 16 squares. We are basically supposed to find out as to if we can make a big square with these small 16 squares or not. Okay, so I'll see what I mean by that. So over here, right? Say for example, so as I said, they will give you the number of squares like in a row. You have to first add all of them to find the maximum number of squares you have. Okay, say for example, your squares are 4. Like the number of squares you have are 4. Can we make a square with this? Yes, we can place the first square here, the second square here, the third square here, and the fourth square here. Now we have a big square, right? Okay, say for example it is 9. Okay, we can still make a square with this. One square here, one square here, one square here, one here, one here, one here, and like this, right? We have 9 squares, which makes a big square. Say for example 16. Even for 16, we can make a big square, right? We will have 4 rows and 4 columns. Now this might not be in the perfect proportions, but you guys get the point, right? If we have 4 rows and 4 columns, we can make a big square. But say for example, we have something like 5. Okay, if we have something like 5, we can't make a big square out of it, right? Because even if we do something like 1, 2, 3, 4, we have a square. But we have this one extra square. Like wherever we add this extra square, we can't form a big square with that, right? Now, say for example, you take even 6, for example, even 6. Even for 6, let's say you do 1, 2, 3, 4. Even if you add 5 here and 6 here, you'll get a rectangle instead of a square, right? So, what is the pattern that you guys are observing here? If you want a big square to be formed from the small squares, your total number of squares should be a perfect square of a given number. Okay, if you see here, a 4 is a square of 2, right? 9 is a square of 3, and 16 is a square of 4. So as you can see, they all have perfect squares, right? Like 2, 3, 4, 4, 9, 16. Okay, but however, for 5, your square, I mean, it's like your square root will be 2 point something, right? It is not a perfect square. Similarly, for 6 also, it will be 2 point something. So basically, how you find out as if the small squares can form a big square is that you have to basically find out as to if they are perfect squares or not. Now, how can we do this? In C++, we have a simple function called sqrt. So if you like just do sqrt of 4, you'll get the answer as 2 and so on. Okay, but here's the issue. Okay, even if you give sqrt of 5, for example, you'll get the answer as 2 point whatever it may be. Okay, now how will you code this out? Like how will you explain the computer as to what to do? Now, if you guys wanted, you could use a for loop. Okay, like you could use a for loop and find the squares like that. But the issue is that the runtime complexity is high. Now, like that's the main reason I recommend using the sqrt method instead of like using a for loop. But how can we do the sqrt method exactly? Now, you guys have to know one thing. Okay, the variable storing the square root will be an integer. Okay, so say for example, I have int s equal to sqrt of 4, for example. Okay, now s's value will be 2. We have to basically check as to if s square will give you the original number or not. So basically we should check if s square is 4. Now here s square will be 2 square, which is 4, right? Which means it is a perfect square. However, if it is not a perfect square, say for example here, instead of 4, we take 5 for example, right? The actual square root is 2 point something something something. But this variable is an integer. So s's value will still be 2, right? Again, you check if s square is equal to the original number or not. Now 2 square is 4 and 4 is not equal to 5. And that is the way we can find out as if a square is a perfect square or not. Okay, like this is the easiest way. So I'll just explain again. Square root of 5 is 2 point something. But since the variable we are storing it is an integer, this 2 point something will get rounded off to 2. Now we basically check if 2 square will give back your original number. Because if you think about it, right, 2 square is 4. 2 square is 4. So square root of 4 should also be 2, right? So now here square root of 4 is 2 and 2 square is 4. Similarly, over here, square root of 5, it should actually be 2 point something. But we get square root of 5 as 2. But if you do 2 square, we'll just get 4. Okay? Now, so like this particular condition won't get satisfied. So now that's the basic idea of how to solve this. Alright? Now let's go to solution now. Okay? So I'll be doing this in C++. You guys can also follow along if you are using C or any similar language. Okay? So I'll first include the modules, include bits/std c++.h, so I can get access to the square root module, or you can just include cmath. All right. Using namespace std, then our main function int main. All right. Now inside of this, we need long int a and b. Again, I'm like using long int here because the input sizes can be massive. Okay. Now I'll accept an a, which is basically the amount of test cases we have. Okay, C in A. I'll just do while A. All right. Now at the end, I need A minus minus, right? Anyways, now I'll do C in B, which is the amount of the amount of squares I have. Okay. Now I have to basically accept all these, right? So I'll just do long int C. Okay. I'll just do long int sum equal to 0. Now sum is basically the sum of all squares. Okay, so over here you have like 14 and 2, right? Sum will be basically holding 14 plus 2, 16. So basically the sum of all squares. All right. Now for int I equal to 0, I less than, okay, I equal to 0, then I less than b, I plus plus. Okay, we have to accept in all the inputs. So we'll just do C in C. All right. Then after that, we have to add it to sum. So sum plus equal to C. All right. Now we'll do the logic that we said. We'll just do long int answer is equal to square root of num. I mean sum, sorry, not num, sum. All right. Now if answer into answer is equal to sum, then we can see out yes, which means it is a perfect square, which means we can build a square with it. Okay, else we can just see out no. All right, that's basically it. Hopefully I didn't blunder anything. Okay, we forgot to put a small semicolon here. Okay, let's submit. Okay, so let's see as to where our case is. Yeah, it should be here. And there you go. It says Happy New Year. Okay, which basically means that it's accepted. Okay, so yeah, that's basically it for this video. Hopefully all of you understood as to how to solve this. If you have any doubts, do leave them in the comment section down below. And that's it for this video, and I'll see you next time. Okay, bye.